So let's start with pointers. Some students are saying, hey, pointers is the hardest thing in C, but for me, I will say yes, it's the hardest thing, okay? So this is why actually I did that this week, which is not the same way we are doing team-based learning. Why? Because I want to elaborate more on this part and make sure that you understood like pointers very well, because everything after that will be built on pointers. Even other courses are building on pointers, and they are not teaching you what is pointers. Like, they are going directly with like their lab, which they assume that you are understanding pointers 100%. So just make sure that you're understanding pointers. I will work with you to understand pointers. I spreaded pointers over 2 weeks, just to make sure that over these 2 weeks, we are going to work on pointers here and then in the lab. And I'm going to include pointers in midterm exam too and in the final exam, just to make sure that you got everything from pointers and you understand it very well, so that when going to other courses, you will not suffer with pointers anymore, okay? So the first thing, just to imagine what are pointers. If you are, for example, having your house, okay, and then you want someone to deliver an email to you, okay? So the only thing you can do is take this guy who will deliver a mail for you, and then you will take to the house. Here's my house, okay? Did you know it? Yes? Okay. When you deliver the mail, just go there, okay? Corresponding to just giving the address of your house, right? So instead of taking everyone to show your house, here's my house, this is the address of my house, you're just giving them the address, here's the address, and you can deliver to it, right? So this is how actually we deal with pointers, that we are trying to giving the address of a certain variable. Hey, this variable in this address, okay? So why we are doing that? Why we are using pointers? I can't say it now. I can't answer this question now. When I will answer it, actually after 2 weeks. So after finishing everything about pointers, I will ask this question again. Hey, why we are using pointers? And you will answer this. But at the beginning, I'm sure 100% all of you will have the question, why we are using pointers? Why we are using pointers? We was good actually without pointers, okay? But again, after we continue, like the Thursday next week, you will find that, yes, pointers are very useful actually, okay? So let's leave this question to answer it with each other. So to define pointers, so pointers, it's like points to another memory location, okay? Which a naive like definition, right? But if we think about it, what pointers are doing, pointers are actually pointing to another memory location. So for example, this is here A and this is B, right? As you can see, A is storing not a variable, not an int, not anything except an address in the memory, right? So I'm saving here, and instead of having, let's say, 10 or 15 or C, which is a char or a string or anything, no. I'm putting here, the value here is an address of another memory location, right? So if you look here, you'll find that A is my pointer. It's actually having an address in the memory, right? And then storing inside it an address, which is pointing to it. Okay, so the pointer is storing inside it an address which is pointing to it. Okay, so an example for that here, as you can see, this is my pointer. Okay, it's in storing here in the memory a memory address, and it is already having a memory address. Okay, so here this is the address of the pointer. This is what the pointer is storing, and when you go to see what is this, you will find it's pointing to a variable which is called var and is storing a value of 10. Okay? Again, this is your house. Okay? And the pointer is having the address of your house. Is it clear until now? Again, the pointer is storing an address, right? And then look at this address, where it is pointing. It's pointing to here. Okay, so it's referring to var and its value is 10. Okay? So just to try to understand it more, pointers are dealing with the memory, okay? Before that, until now, everything you did, you didn't play with the memory. You didn't use it. The only thing you was using, you were just having a variable, right? And leaving the compiler to assign a memory location, right? and having the address and everything. Now you are the one who are going to play with this, play with the memory locations and addresses and everything. Okay. So when we are dealing with pointers, we are dealing with two operators. The first one is the AND operator, and we saw it before, right? Where? When we are using scanf, right? And we used the AND operator. Why we used the AND operator? We said at this time, hey, we will know that later, but at least now know that you are saying, hey, take this to the address of A, right? If you are scanning or asking the user to enter a variable, right? And then you are saying scanf and then AND A, right? This means that go to the address of A and store whatever the user entered, right? So we know before what is the AND operator, and we dealt with it. And again, every time you see this, read it as address of whatever in front of AND. Okay? Is it clear? Okay. So the other operator, which is the asterisk or star, whatever you want to say it, what is this denoting? It's denoting the value. So in this case, if you are reading this, it's better to say value at address and whatever, based on whatever is written here. Okay? So again, we have the AND operator, which is just saying, hey, here is the address of, and the asterisk is used for the value of the address, okay, or to get the value of the address. So, for example, if I want to get the value here, I can get it using asterisk pointer. And in this case, it's going to get the value which is 10. Okay, so motivation behind pointers. Again, as I said before, still we are not going to answer the question why we are using pointers, but at least the main motivation is when C was invented. It was invented like 40 or 50 years ago. The computer at this time was slow and is not having enough memory, right? So this is why they dealt with the memory. Now I want to go to the memory, I want to delete, I want to add. So in this case, they want to deal more in depth, right? Low-level programming, going to the memory and deal with it. This is the first thing. The second thing is that they want to optimize the program to be faster, to work faster. The third thing is that pointers are dealing efficiently with arrays and strings, okay? So as you saw, the arrays, you are having the first element of the array and then the index of the next elements, right? Next week, we will deal more with arrays and pointers and see that without pointers, we will never be able to deal with arrays. And again, without pointers, we will never be able to deal with strings because strings are array of characters, right? So a special case from arrays. So without pointers, no way to use arrays, okay? The last thing actually is allocating memory dynamically. What the meaning of that? Every time you are dealing with arrays, you are saying, okay, A of 10. This means that A will have 10 elements, right? Can you, within the program itself, change 10 to 20? Can you expand your array? Within the program, you already compiled and A of 10. Can you, within the program itself, change that? No. But with pointers, yes. Using something called dynamic memory allocation. In this case, while the program is running, I can change the allocated memory to a different memory, okay? And we will see that with each other dealing with memory allocation. So, next thing, how to declare a pointer. So, pointer declaration is very easy. First thing, you are dealing with the pointer based on whatever it's pointing to. The pointer is pointing to an int. In this case, while declaring it, you will say int asterisk pointer. As you can see here. It is pointing to a double. You will say double asterisk pointer. Whatever you are going to point to, you have to declare it here. So the type is based on what is this pointer pointing to, okay? And then as you can see here, from all declarations, everything is exactly the same as before, except that you're adding asterisk here. So anytime you're declaring pointer, you have to put asterisk there. Why? To tell the compiler, hey, this is a pointer. Okay, it's not the regular variable that I'm dealing with. Any question? Okay, so let's have a very toy example, which is just having here int data equal to 50, and then int asterisk p What is this? It's a pointer, okay? And it's pointing to int or integer. And then finally, p equals to and data. Let me remember, what is this? And here, address of, right? So this means that I can read this as the pointer will store inside it the address of data, right? So now, the pointer is pointing to data. And how we know that? Because here, I'm writing this line, which is saying that my pointer, the value inside the pointer will equal to the address of data, right? Is it clear? Okay, so this is what will happen. In the memory, you will have data equals to 50, and then the pointer will just point to data, right? Because now you have the address here. Let's say the address here is 7F, okay? And the address here is AF. What is 7F and what is AF? Hex. Most of the time, while we are dealing with the memory addresses, we are dealing with hex. Why? Because if you wrote it in binary, it will be like, at least you're writing 16 bits or 128 bits, right? It's very hard to write it zeros and ones. This is why we are just representing it in hex. While in the computer itself, it's just binary, because the computer is just understanding zeros and ones, okay? But while we are dealing with the memory locations, we are just writing it in hex. So in this case here, we will have 7F. What the meaning of that? The pointer is pointing to 7F. And going to 7F, we find that we have data, and then the value inside is 50, okay? So what if I want to change 50 into 100? If I want to change 50 into 100. The regular way of doing it, I will just say data equals to 100, and that's it, right? And now you will return back to the question, so why we need pointers, right? Because I will tell you now that I can change it using the pointer by just having this. Asterisk p equals to 100. This means that if you remember the definition of asterisk here, returning back, saying value at address, right? So here I'm saying value at address p equals to 100, and this will change the value here from 50 into 100. So now we have two ways of changing it, right? The regular way that you know it, just writing data equals to 100, and the new way of doing it, which is using the pointers, asterisk equals to 100, and that's it, okay? So these are two different ways to change it. Okay, so let's look now at just a small program which is dealing with pointers. So here we have void main, int, asterisk, pointer int, and then int myvar, and here pointer int equals to and myvar. So what happened here? This is the regular way of declaring a pointer and then assigning to the pointer an address, right? And here the pointer is actually pointing to myvar, right? Which is the same thing we did before with the last example. Again, declaring the pointer and then going to declare an end variable, and finally assigning the address of the end variable to the pointer. So from here, you'll find this is a declaration, and from here, using the AND operator to get the address of myvar and assign it to the pointer, okay? Let's look here. Int a equals to 1, and then here, int asterisk pointer to a equals to and a. From here, you can see that I can declare and initialize the pointer directly in one step, right? So here, declaration of the pointer, right? And assigning the address of the pointer directly. So we can exactly the same as any regular variable. You can declare and assign at the same time, okay? So from here, we have printf the value of a as %d and then a. This means that I will print here 1, right? What about the next line? it will print also 1, right? Because read this, value at address here, right? And this address is looking at 8, so this means that it will print whatever in whatever in A, which is again 1. Okay. Another example. Starting here, double A equals to 10, and then double asterisk pointer, so declaring the pointer, and then finally P equals to and A. This means that this pointer is storing inside it the address of A, right? And then going here, printf percentage %d asterisk P. What is going to print from here? Just going to print 10, right? And then asterisk P equals to 200. What's going to change now? A is going to change to have a value of 100, right? So you can look at this in this way here. This is the memory. And within the memory here, let's say this is address 10F. And I have here A. And it's having the value 10. And let's say we are here at address 25A. And this is the address of P. And inside here we will have 10F, right? Right? And from here, when I'm saying asterisk P equals to 200, this means that the value in address P will just have a new value, which is 200. So in this case, I will just look what is the address here and go to 10F and change it from 10 into 200. Okay? Any question? Okay. Let's play here. So we have int asterisk pointer, so declaring a pointer, and then int var equals to 10, declaring and initializing a variable, which is int variable, and P equals to and var. So again, the same combination, just to have a variable and a pointer, which is pointing to the variable, right? So let's go to the first printf, which is percentage %d and var. So what is going to print? What's going to be print here? 10. The next line of printf is percentage %d and then asterisk P. What is going to print? 10. And then the next one, percentage %p, the first time we see percentage %p, right? Which here is just printing an address, okay? And then and var, so it's printing the address of var, right? And then the next one, percentage %p, and then P. What are we going to print here? Address of var, right? All agree? Because this is the address inside P, right? So this will just print this one. The last one, percentage %p and then NP. This means that you are going to print the address of the pointer itself, right? Not the address of the value inside it, which is pointing to another variable. No, this is the address of the pointer. If we return it back here, we have to distinguish between the address of the pointer and the address that the pointer is storing, right? How to get this? To get this is P. How to get this? This is and P, okay? And here's one trick I can play with in the exam, okay? Just giving you some printf statements and just let you know, okay, here are the addresses and here are the values and everything. Please give me what will be printed from this statement, this statement, this statement, this statement, okay? So if you run this program, you will find that you are getting the following values. The first print will get 10, the second 10, the third, the address of var, the fourth, the address of var, which is inside the pointer, and finally, this is the address of the pointer. And this is demonstrating the output. So if you look to the output here, you'll find that here is the pointer storing inside it the address of var, and it's having its own address, right? And here var and the value is storing. So the first printf that we have is printing 10 by just going to var, right? The second one is trying to see what is the value that the pointer is pointing to, which is again 10. So the second here is 10. The third one is printing the address of var. This is why it's printing this one. The fourth one is printing the value that p is storing inside it, which again is address of var. Okay. The last one is printing the address of p. Okay. Think. Yep. We have it here, if you can see. So it's called ntrue. So if you can see here, it's printing the same thing, right? But one more thing I want to tell you here, that these addresses is different from the addresses in the slides, right? And if you run this program, you'll find that your addresses are different because everyone's having his own memory with the memory addresses, right? So, and most of the time, when you are declaring, let's say A, the variable A, it's just going to any random memory location, just the compiler choosing any memory location and just having it, right? So this is why every time you're running it, you are getting a new address assigned to it. Okay. Yes.
Now, point should be the same name as the variable, so like can point to p or p.
Nope.
No.
This is why every time I'm just trying to name here, I'm just trying to have like p, and then here is the variable as var. But you can't have the same thing, but just using asterisk, because the asterisk is just defining that this variable is actually a pointer. So if you have a regular variable and the same name with the pointer, this actually will have a error in the compiler. Okay. Okay. So this is another example. Let us go and see it directly in Notepad++, and let me try to. Okay. So here's another example. Okay. We are starting with int main, and then after that having here pointer declaration, right? Which is called here PC, which again, most of the time when I'm naming any pointer, I'm trying to put anything to tell what it is pointing to. So here, PC, I'm just trying to say pointer to C, right? Or you can see, you can name it as C pointer. So for example, here, you can just change this name into C and then pointer. But most of the time, if you have a pointer which is dedicated to a certain variable, try to name it to something related to the variable, just to tell you while you are going over your program that this is always referring to this pointer. And then we have here declaration for C. And then part one, we have C equals to 22. And here, we are just having printf and C. So this means that we are printing the address of C, right? Right? The address in the memory that C is there. And then here, print C, and then %d. This means that I'm printing the value of C, right? So until now, we didn't deal with pointers. Until now, the first part here, we just dealt with the regular variable, and we have the address of the regular variable and then the value of the regular variable. Yes?
Why does the first printf statement have %u?
%u is unsigned. So it's giving unsigned number, which again, since we are not dealing here with any signs, so it's the same as %d. Okay?
But it shouldn't it be %p?
%p, %u, both of them are used for printing pointers. okay? Because again, pointer value it will never be negative, right? So we can use unsigned with that. So this is why I'm just having different ways of representing addresses of pointers or addresses of any variable, okay? Part 2, we have here the pointer is now pointing to variable C, right? Because here we are saying the address of the pointer would be assigned to address of C. And then here, printing PC by itself, this means that it's going to print the value it's storing inside. And the value inside is the address of C, right? And then here, asterisk PC, this means that I'm going to print the value that PC is pointing to, right? And again, what's the value that PC is pointing to? It's the first initialization for C, which is 22, right? So I'm expecting that part 2 is going to print 22. In part 3, we have changed C into 11, right? And then using, again, the pointer to print the address of the pointer and to print the value inside or the pointer pointing to, right? So what we are going to print this time? What number? What we are going to print here? 11, right? Because again, we said we can change the value of C in 2 different ways. Using the pointer or using the regular way, which is just assign C to a different number and that's it, right? And this is what we did here. The last part is just changing the value of C using the pointer, right? So here, the value of the address in PC will equals to 2. So you are now changing it from 11 into 2, right? And again, printing the address of C and the value of C, which will give this time 2, right? So if we run this here, you'll find that part 1 is printing 22 and the address of C. Part 2 is printing 22 and the address of the pointer. Part 3 is printing the address of the pointer and 11. Part 4 is printing the address of the pointer and finally printing 2. Okay? So again, here we changed the value of the pointer using, or value of C using C or using the pointer itself. Okay, so common mistakes with pointers is very easy to understand, which is if you try to assign a value to an address or vice versa. How you can know that? For example, here you have C as regular variable and PC is a pointer, right? So if you try to say PC equals to C, okay, what is PC? Let me mark it here. What is PC? Using PC as it is. Is it a value or an address? It's an address, right? Right? So here I have address. Okay? Equals to C. C here is just value. Can you assign an address to a value? No. So you are going to get error, right? So every time you are dealing with pointers, try to look at the right-hand side, left-hand side, you are dealing with the same thing. If here is value, here must be a value. If here is address, here must be an address, okay? So every time you are dealing with pointers, you have to make sure that you are dealing with both of them, right? So both of them are the same thing. So here, PC by itself, PC is an address, right? Asterisk, PC is a value. So in this case, to correct this one, you have to put and here, put asterisk here, right? Or put and here, just to say this is an address and this is an address, or this is a value and this is a value. Okay? The same thing for the next one. This is value or address? Value, right? Again, from the first slide, we said if I have the asterisk, this can be interpreted as value of address, whatever, right? So in this case, this is getting a value. So here I have value. Okay, and C is address, right? So this means that you are saying a value equals to an address. Is this right? No. So mainly this is the common mistake if you are dealing with pointers, that you are assigning a value to an address or address to a value. If you look here, you'll find that this is correct. This is an address, this is an address. So an address equals to an address? Yes, that's totally fine. And here, this is a value, this is a value, so this is totally fine. Okay? So, yes.
These cause compiler errors or logic errors?
Compiler errors. Yeah. Because again, value and address can be assigned. So for example, if your value is 50, you are trying to say, hey, compiler, try to go to the memory and find a value which is 50. And most of the time, the values in the memory is totally different than just 50. Okay, so this is why the compiler will be confused. I can't find this in the memory, and then we'll return back an error. Okay. This is another example. We have here initialization for two variables, m and n, and then a pointer. Okay, and then giving you here the address of the pointer is 2300, and then the pointer is pointing, or the value stored at the address that the pointer is pointing to is 10, which means here it's pointing to m, because m here, its address is 2300, okay? And then the next line, and n, okay, which is the address of n, which is 2034. And then here, p equals to the address of n, right? So this means that you changed the pointer from pointing to m to pointing to n. So now the pointer actually, you can change it from pointing to this variable to point to this variable to point to this variable. You can change it totally, whatever variables you want to change, okay? So again, the pointer is not assigned to a variable and that's it. Within your program, you can change it. First, it was pointing to this variable. Second, it will point to another variable. Third, it will point to another variable, and so on. So the pointer can be changed. Just here, as you can see, p, which is the value stored inside the pointer, right? Now will be the address of n. At the beginning was the address of m, right? So now we changed it to another address. And here, getting the value of p, you'll find that it will get the value inside n, not m, right? And then the next step, m equals to asterisk p. What we are doing here. The value of m now will get the value that p is pointing to. What p is pointing to? N, right? What is the value of n? It is 20. So now m will have the value of 20. Can you see what is happening? Confusing? Again, so here at this point, I have p pointing to n, right? So it's pointing to the address of n. And then what is the value of p? It's 20. Why? Because it's now pointing to n, which its value is 20. And then here I'm saying m, its value will be changed based on wherever the pointer is pointing, right? So the pointer is pointing to n. This means that m will have the value of 20. Okay? And again, another error here. M, which is a value, can equal to an address? No. So you can't do that. You can't say m equals to p. How to correct this? Since this is a value, you can put asterisk here to correct it, to be very similar to the one before. Okay? Or put and here, okay, to p equals to this one. Okay? Here, you can put and in front of any number, because this is a number, this is a value. How you can say, I want the address of the value? Nothing called that, right? The value is stored inside the memory, so you can't say that. You can get the address of the variable that is storing the value, but you can't get the address of any number. Okay. So next, we have null pointer. So the pointer, when you start declaring the pointer, just declaring it without assigning any address, what is the address that the pointer pointing to? It's null. It's not pointing to anything. Okay? So again, if you are assigning or declaring a pointer, until now the pointer is declared, right? It's not assigned to any variable. It's not pointing to anyone. So where it is pointing? It's pointing to null. It's pointing to nothing. But actually, inside the program, the compiler assigned an address to the pointer if it is only declared. What is the address? Address 0. What is address 0? It's not pointing to anything. Even if the memory is having address 0, we are not having access to this address. So most of the time, you will have the pointer is pointing to null if it is declared only. Okay? If you want to look at its address, it will give you its address 0. Okay? If you want to assign any value, the compiler will say, hey, stop until now. Don't continue, please. You are just missing everything, right? So let's see. Very simple code for this here. So the code here, it's just having int pointer equals to null. It just initialized to null. And then the value of pointer is, and then here printing percentage %x. Again, what is percentage %x? This is printing hex. Okay? So until now, you can print any address using %p, %u, and %x. These are 3 different ways of printing addresses. Okay? So %x actually is saying, hey, printed in hexadecimal. Okay? This is why actually you find that any number which is okay, so if you look at this number, any number starting with 0x, it's saying, hey, this number is written in hex, and this is the hex number. Okay? So if you remember, if I can return back to the slides here, I don't have time, but if you return back to the slides and see any addresses we had, or let me just go here. Can you see here? Starting 0x. 0x is not part of the address. It's just saying that, hey, the number after the x is written in hex. Okay? So here, if we try to run this program, we'll find that the value of pointer is 0. Okay? The next error is not supposed to be because I changed this here. So let me okay, so it's giving 0. After that, if you want to play with it and say here assign, so asterisk p or pointer equals to 100. So now you are saying, hey, assign the value 100, but until now you don't have any address for the, right? It's just pointing to 0. So if you have this and save here, compile again, run again. So it's going to run, but it will give you segmentation fault because the compiler went to address 0 to store this and wasn't able to access it. Okay? So every time while you are dealing with the lab and you have this error, make sure that you are missing something with pointers. 100%. If you get segmentation error, core dump it. So this means that something happened in the memory. Now you are playing the memory, so you have different error. Okay? Is it clear? Okay. So I'm going to stop here. I published the application activity for today. I know that we are not going to do it in the class, but for you to practice with it, it's not graded, but please try to attempt it. And again, it's on the discussion board. So try to do it and then paste it to the discussion board if you do it individually, or try to do it with your group and then just paste it there, okay? And doing it with your group, you can do it on Canvas. You have discussion with the group, so you can just paste your code there or discuss the code there, and then finally do it on discussion board. You don't have to gather physically to do it. You just can do everything on your own discussion for your group, okay? Thanks very much, and we'll see you next Thursday.